Welcome back to part 6 of our DIY Autonomous Mobile Robot Building series. If you've missed any of parts 1 to 5, don't worry, you can find the links in the video description, or you can access the full playlist at the end of this video. In part 5, we conducted operational testing of the various components connected to the circuit board and confirmed that our design works perfectly. Now in this video, and in the next couple of videos, I'll take you through the design process. Initially, I designed the chassis without a finalized body design, resulting in an over-engineered structure that somewhat resembled a station wagon. Instead of just slapping body panels onto this chassis, I decided to start afresh by designing a robot body first. And here it is, a sleek aerodynamic design. Believe it or not, I'm going to create this robot body without a 3D printer. I'll be making the molds from scratch, and I'll use vacuum molding for the various curved panels. I'll be using a 0.5mm thick Tamiya Plate plastic sheet for most of the body shell. But there's more to this story. The youngest member of my family insisted on a deluxe version, complete with this beak and tail. Some might say it resembles a duck, but I don't see it personally. Well, okay, it's a duck, okay? I'm making a robot duck. If you've been following along since the beginning, don't worry, you don't have to build a duck like mine if you don't want to. I'll show you how I modeled this design in Fusion 360, so you can create your own unique non-duck robot design if you prefer. So open up Fusion 360. I'm just using the free version. First, we'll start by drawing the left and right wheels that will connect to the left and right servos. You might remember from part 1 of this series me showing you these black lids, which are 113mm in diameter, for use as left and right wheels. These are the same wheels as the prototype design I just showed you. However, upon finalizing the design of the robot body, it became apparent that the wheels need to be scaled down in size in order to remain in proportion with the head of the duck. So I'll be using these much smaller diameter lids instead. I will not keep them pink. I will color them yellow with an epoxy yellow paint, which hopefully should hold, even though they are made of PP or polypropylene, which ordinary paint would not hold onto very well. I've created a component and labeled it wheel. Create an outer diameter of 66.4mm because that's the size of the outer diameter of the new lids I'm using now. As you can see, I have an inner diameter of 64.4mm so that the peripheral thickness is 1mm. Anyway, extrude the thickness in the middle there by 2mm. So I might as well do some knurling because the lids I'm using are knurled. To do that, we edit the sketch. I've put in a dimension from the top of the outer circle of 0.5mm, so pretty small. Draw a 45-degree line from there toward the left and then make the end of that line coincident with the outer circle. Then mirror that line for the right side to create a V-shaped notch. Now we can create a pattern by selecting circular pattern from create. Select those two sides of the V-shape as objects. Select the center of the wheel as the center of the pattern, and then add the quantity. So the default value is 3, so let's try 30 for a start. They're still quite widely spaced apart, so we'll ramp that up to 100. Looking pretty good, but not quite there, so let's try 120, which is better, but could still do with a few more, so let's try 150. Finish sketch. Okay, now we can select the outer rim in one selection, which selects the entire rim minus the notches. I adjusted the extrusion amount down to 15, or minus 15 actually, and added a 1mm non-knurled rim on the back, just like on the actual lid. Then I did a 0.2mm fillet on the entire component, and that is the wheel completed. Now I have opened up a new file, selected sketch, and here I am selecting the vertical YZ plane. Create a horizontal construction line, 135mm, and a 100mm vertical construction line. These lengths are fairly arbitrary. Select sketch again, and this time select the vertical XZ plane. put in a rightward extending horizontal construction line at 50 millimeters. Again, just an arbitrary value. I might label these sketches so I don't get lost. Front elevation for the current sketch and side elevation for the previous one. Dimension the left construction line. Finish sketch, and there we have the basic construction lines. So let's insert the wheel into our current design by right clicking it and selecting insert into current design, and we can initially move the wheel along the X direction by 50 millimeters. Let's make a copy of that and move it over to the other side, and then rotate by 180 degrees. As you can see, each wheel is located at differing positions, so let's align each inner face to each end of their respective construction lines. Okay, here I've progressed on to sketching out the outline of the body. I've been using the spline tool for most of the curves, except for the circle surrounding the wheel. Now, because we are only constructing a body outline for reference purposes, and we won't be extruding any of the shapes, these sketches for the body do not need to be constrained. The spline tool is quite easy to use. You need to select a starting point, choose arbitrary points along a path of the curved line you are creating, and then select the end point of the curved line. Here I am designing the tail shape. Okay, but once you have sketched the curved line with the spline tool, you can select one of the black points on the line, right click to display the menu, select move copy, and I find it easiest to grab the little square that allows you to move the point in both the vertical and horizontal directions. So you can move it around just like this. Just finish off the tail part, and there we have the side elevation finished. Here I've created another sketch for the front elevational view with a 76mm circle for the initial shape of the head. Again, these are just reference lines for when we use the form tool to create the 3D body. Well, I think the head will look better if it's not a perfect circle, so we'll put in a random reference line and use the spline tool to sketch a curved line inside the lower part of the circle here. Move the midpoint of the curve. Then I just use the mirror tool to do the other side, and then chop off the original line of the circle with the trim tool. Okay, now it's time to sketch the front view of the beak. You can swivel the drawing to confirm what the various dots on the vertical line here represent in the side elevation so that the front view of the beak aligns properly. As you can see, I've put a horizontal reference line at a length of 16.5, which I think makes it a bit easier to sketch the line with the spline tool because you're providing a specific end point for the curved line. So once again, you can select a black point and right click, select move copy, and move the point to adjust the curvature. Okay, so we have the right side of the beak, so let's mirror that. I've deleted that initial dimension of 16.5 to free it up for further adjustment. You can play around moving the points on the curves until you arrive at a profile shape that you are looking for. So it's really just a repetition of the same principles to construct the outline sketch of the elevational views. So here we have the initial neck, which will be changed later, and the bib portion sketched in. Also, because the lines created with the spline tool don't automatically constrain upon arriving at a destination point or line, you should select the tick mark that shows up in order to finish the line. To continue, click here for part 7. If the link is not showing, then part 7 is not quite ready, but should be ready very soon. Thank you for watching.